So good morning to everybody. It's a pleasure to be here. Thank you for the opportunity. I'm going to present today some use cases of some open sources, but mostly about 4DIAC in our company, where we also develop some kind of technologies for advanced process control, real-time optimization that we run on the edge through 4DIAC, okay? So first of all, I would like to say that open source software gives us the opportunity to make some things very astonishing. So that's why we are making impossible possible, okay? And in our vision, we want to create the industries of the future, okay, through applied sciences. So there's a lot of scientific things that we can bring from the university, and then we can bring from the industry, and then we would like to take it from one industry and bring to another, take it from the university and apply it on the industries, okay? And our values, we want to make it happen with a clear purpose, okay? We have purposes in our company, and we focus on that. And we do it in an ethical way, and we form people. This is very important to us to form people, because we understand that professionals of the future, they might be formed today, and not all the time people are doing that or thinking about that, and sometimes we can do that inside universities, but you also can do that inside companies, and that's what we do, okay? So this is who we are. We have a young team. I mean, I'm not the youngest person there, maybe I'm the oldest one. And this is a good point about doing open source, because some people get scared about what we're doing, because we're putting people with 20 years old, 21, 22 years old, doing the full advanced process control in an industry, real-time optimization, and we teach these people inside our company, and this is working well, okay? So how complex is it to go inside a big company, a big industry, and start taking data-driven decisions, okay? So in 6 years, that's what we could do. We are inside British American Tobacco. We are inside Raízen, which is a joint venture between Shell and a Brazilian company for sugarcane, alcohol, and sugar, of course. And we're doing in logistics with VLI. It's a big company in Brazil, invested by Mitsui, invested by Brookfield, by Vale, and Dairy Partners Americas, among others, okay? So how to face the biggest engineering and consultancy companies in the world, and how to deal with the biggest clients in the world, okay? Well, we do it all the time, and we are confident that we know exactly what we are doing, okay? It's not an adventure to us. We are experienced guys, and we are teaching people, and we are passing our experience to our employees, okay? So basically, we are the unique industrial full-service company in Brazil, based on software, hardware, plus consulting. What is the Aimirim world? Henry was talking about there's a lot of projects, and these are the projects that we are using right now, okay? Maybe there are one or another more, but we are using these projects right now. Some of them for digital twin, for example, Modelica, we have some way to totally model a plant and commission on the model the advanced control and the real-time optimization, check results before, and then deploy it on the field, okay? And 4DIAC, of course, so a lot of solvers. And basically, we do that to make data valuable. So industry generates a lot of data, and you shall know what to do with this data. Okay, so advanced control is something you can do with the data to take some kind of decision. Real-time optimization, of course, is another kind of decision you can do. But also, industry shows more needs than that. For example, when somebody says that you're going to use advanced control and you're going to have some return over the investment, and then the guy wants to know what is the return. Okay, so advanced controls reduces variability. So how can you take variability reduction and show to your client the way the return they will have by variability reduction. Okay, we can do that through data analytics, okay, but we can do that also with another kind of physical digital twins. And also real-time optimizations. It's a kind of decision that you can take with your data, okay? So you're always needing data. And we also have some technologies about sensors. We developed some intelligent sensors where we collect some fundamental data, and with this fundamental data, we send it to the cloud and make some scientific calculations, and then we bring back some relevant results to the client. Also, we have some, for manufacturing, intelligent recommendation systems. And when the recommendation, it's not a recommendation anymore, but it can be an output of advanced control or optimization, then you have the full capacity planning that we are deploying right now in the second generation ethanol, okay? So our company is not about software, hardware, and open source. Our management, it's kind like open source, okay? Because we don't have a very straight hierarchy inside our company, so it's something we have to deal to make this model of a company. If I can, I could say that our company is like a copycat of a university laboratory that we brought to the market, okay? And now we have some things closed, then we can scale the model. So it's not about the model of the software, it's not about the technology, but it's also about management, okay? So we have a very strong culture, and that's something that we don't open, we don't give up about our culture, okay? It's very strong to us. So I'll show you some step-by-step examples here. First of all, it's important to see that we deploy our technologies on the field with the technologies on the edge. Why? Everybody was telling here yesterday and the other day that there is a problem, integration IT with OT. Okay, so imagine the scenario that you go to a client and just say, I have here a hardware, okay, it's a single board computer, and it's embedded with a real-time optimization. Then you're gonna plug in your code generation system, you're gonna have an optimization and advanced control, and you don't even need to talk to IT people, okay? So people used to like it. Of course, at some time, you need to make things better and talk to IT people. But you have the opportunity to start generating value before you solve the problems between IT and OT. And this is only possible because we use it for the act. It was a strategy to us when we decided to find something that does what 4DAC does. And hopefully we found 4DAC. We deployed 4DAC inside the hardware. And 4DAC allows you to build blocks. So we have, but the blocks, they can be, for example, written in low-code language, such as Fortran, C++, C. And then you close this small block, deploy it in the hardware, and bring the hardware to make what it has to do, for example, in terms of advanced control in a facility. So what's the point? For an employee from Aimirim, a very young guy or girl there, what they have to do? They have to link blocks and put play. Then it's working, okay? So I have deployed an advanced control in 3 days, and I have deployed a real-time optimization in 30 days. I think it's fast, okay? And I don't even need to talk to IT people. So this is the basic architecture. And some results from Raízen, the joint venture between Shell and Brazilian group. Mean reduction of variability of 35%, fuel consumption 5.1% in 15 power plants, okay? The mean efficiency increasing 3%, and they published it on the newspaper a return of 100 million Brazilian reais, which means around $25 million in one year, okay? And with these results, we became the partner of this company. And we are present on their ESG report because they are an open company, okay? So more detailed results on on each facility that we were in 2020. Now we are in 15, okay? So the second case, it's the biggest manufacturer of tobacco in the world. They have a facility in our city, in Uberlândia, in Brazil. So the architecture is the same, but the point is that the first process we're going to deal with them, it was drying section of tobacco, and they used gas as fuel, okay? So we became a little bit aware about that because it's a bit more dangerous to deal with gas. So what we did first to this client, we generated a lead to predict the savings for this guy. So we expected an efficiency increase of 6% and then a variability reduction of 30%. And then the client said, okay, move forward. So we modeled the process of these guys, and we have experience on modeling engineering problems from CFD, for example. We have our own CFD software that came from my PhD. But CFD sometimes doesn't pay the bill, and we need to do things faster to the market, okay? So we started a 0D modeling of processes, okay? So we did this model of this process, the digital twin. After we did the digital twin, we deployed the technology, the advanced control, and the real-time optimization in the model, okay? Then we could check what will happen with our digital twin, with our advanced control, and with our real-time optimization in the model. So here are some results. There we used an MPC, but we have more advanced controls. We have adaptive advanced controls we developed. Then we tested also the real-time optimization, never forgetting to produce what is needed and produce it in the most profitable way. In this case, it was around 60 variables. So let's see, 60 variables in a single board computer with 4 DAC deployed in the hardware, no talk to IT people, okay? Directly communication with the PLC, and we have communication with Rockwell, Siemens, any Modbus, GE, ABB, okay? All blocks in 4 DAC. And then we deploy it on the field and have the results. And we show the results of 50.31% in variability reduction and 5.30% on fuel consumption, which is close to what we said to the client. It was 6%. So this client got with this project an ESG seal. They have some steps about it. So they have a goal for 2040, and they got it in 2021 because of our technology, among others, okay? But that's on the newspaper, okay? The implementation of process control in the tobacco dryer. Neutral carbon, okay? So the client tree, and the last use case we would like to present to you. This is a full historian system, very scalable, okay? It was built with the view of IT people. So we use Prometheus, which is something that IT people uses for observability. And I'm quite sure that this one is the most scalable technology for collecting data from industry that you're gonna see in the market with some different thing. We're gonna open it next month to open source, okay? Hopefully with Eclipse Foundation. And if you'd like to download it, it will be there for you, okay? Fully open source. So that's it. The world will need deep techs to bring science to the next generation of industrial processes automation. That's what we are doing, and that's where we are winning, okay? We are very proud of what we are doing right now. We're growing by our own. We are bootstrapped. We have no investors, and we're doing this with open source. Thank you very much.